Hey everyone, Mr. Marquardt again. Hope you guys had a great weekend with some beautiful weather out this weekend. Hope you got a chance to get outside and enjoy and do some fun stuff with your families. A couple of reminders. Last Friday we had a formative quiz, so please make sure you go on to It's Learning and take that if you haven't had a chance to yet. Homework collection for this week is going to be today's lesson all the way through Thursday, so it's going to be 1.2.3 all the way through 1.2.5 Part B. And again, please come into office hours if you guys are struggling with any of the stuff we're doing in class. For today, we're going to put the answers up from the homework from last week, and then we're also going to do a couple problems, and then make sure we have our toolkits out, because we're going to need those at the end to add a couple more things on too. So pause your answer, or pause your video here. So if you want to check your homework answers, again, if you have any questions, come to office hours. Let's get to math. So function machines is what we're talking about again today, and functions in general. We're going to learn a new way to notate functions to try to represent data a little bit, or represent information just a little bit easier for us. So how we've seen this in the past is just like this with our function machine. So we have our input of x, we have our function in the middle here, where this x equals 6 gets plugged into that equation here. So when we do that, we would get something like y is equal to -6 over 3 minus 10, because that 6 gets plugged in right here, which would look like this, and then we would get our output, or our y value, of -12. So that's what we've seen before. Today we're going to add to that just a little bit, but first we're going to start by looking for relationships between some data here. So if we look at this table of our x inputs and our outputs, which are the y values below, what is the relationship between the input and the output values? If we can, we're going to try to write an equation for this relationship. And what family is this relation, or is this function? So if we take a look here, if we look at our outputs, I think if we look at -1 and 1, those both have the same output. -2 and 2 both have the same output. -3 and 3 also have the same output. So this table looks somewhat symmetrical in a sense. So what that means to me when I'm thinking in a table like this and see something symmetrical, that this is probably a quadratic function, or something that's going to give us a parabola that looks like that, right? So if we take a look here, our 0, when we plug in x is equal to 0 for our input, our y is -1. So that tells me that our y is equal to something -1. So now let's take a look at the other parts of our function here. So if we were to plug in 2, for example, so plug in 2, right? So when we plug in 2, we know from last week that in order to get a quadratic function, it's going to be something x squared, right? So if we look at like 2 again, like I said, plug in 2 for our input here. If we do 2 squared, that'll get us 4. So if we do y is equal to 2 squared minus 1, this is 3, or sorry, not 3. This will be 4 minus 1, which is y equals 3, which is what we have right there. So if we do -2, and then we should get the same answer. So I believe this is what our function would look like for that table. So let's take a look at the next one here, 153. If we change the notation a little bit, a function works like a machine, but we're going to add a different notation. So the notation f of x represents the output when x is processed by the machine. So that's a big one here. So the notation of f of x represents the output when the x is processed by the machine. So it is that little thing right there. So f parenthesis x parenthesis is read as f of x. So in this notation, the f of x replaces the y. So this is a little easier to use. So if we look at our function over here, when we plug in 3, what that's really saying is 3 is equal to 3 squared minus 1. So basically when you plug in that x, it's kind of reminding ourselves what our input's going to be so we don't get confused. So that f of 3 is going to be equal to 8 because that's 9 minus 1 like it says up here. So that is what f of 3 is. So for the output of f of x equals x squared minus 1, when the input is 4, find f of 4. So again, we're going to do the same thing like we just did here. So if we do the same thing, we have f of 4 is equal to 4 squared minus 1. So f of 4 is equal to 16 minus 1, which is going to be equal to 15. All right. We can do the same thing for that same function for f of -1 and f of 10. So f of -1 was on the last page, so we should get 0 for this one. I'll let you work through that one on your own if you want to. Then f of 10 would be equal to 10 squared minus 1. So this would be 100 minus 1 equals f of 10. So f of 10 would be equal to 99. So again, we're just taking our input, which we have in that x spot here, plugging it in, and that's the value at that specific input. Right there. All right, so on to the next one here, part C. If we know the output of the function is 24, so we know that the output is 24, what is the input? That way, if f of x is equal to 24, like it says right here, what is our x value? How can we figure that out? So basically, we need to work backwards here. So if we know that f of x is equal to 24, so we know this value, we know that 24 is equal to x squared minus 1. So if we do a little algebra here, we can add 1 to both sides, add 1 to both sides, so we get 25 will be equal to x squared. So in order to get x by itself, we would have to take the square root of both sides. If we take the square root of 25, we would get 5, and that should be equal to x. But I think there should be one more answer than just 5, because if we take -5 and square it, can we also get 25? I think the answer is yes. So we would have to say plus or minus 5 here. So there's more than one possible input that's going to get us 24 for a result. So if we check ourselves to see if we did our work right, if we do f of 5 equals x squared minus 1, we have f 5 is equal to 5 squared minus 1. So this is going to be 25 minus 1, which is 24. So that means that we did our work right over here. And then this will work exactly the same if we plug -5 in, because if we square -5, we still get positive 25. So if we take the square root over here, it's plus or minus 5, so we get the same result when we plug it into our function again in red over here. All right, let's move on. So in 54, I'm going to let you work through this one on your own. So what I want you to do is find the relationship between x and f of x in the table below and write the equation. So again, this top is our x values, this is our input. F of x is our output. So look for these 3 columns to help get you started. Look at the relationship between our input and our output. So if we look at 1 and 1, we plug in 49 and we get 7. If we plug in 25 and we get 5, what's the relationship between these 2 numbers? So I want you to take a look at this one, fill in the rest of that chart, and try to figure out what the function might be for this table. 55, I'm also going to have you do on your own. These are really good practice problems. Plug in our input values over here, get our outputs. There are some where we know the outputs and we have to find the input, like part F. Some of them might not work. If they can't work, make sure you explain why. Go ahead and check your answers on the filled in video. or if you have any questions on anything, why it will or will not work, then please come to office hours and ask. All right, so the way we can use this information on a graph and find points a little easier, what is the output of the function if this parabola right here is our function? What is the output of the function when the input is 2? That is, find g of 2. So if we look at this graph on the right, if we go to where our input is 2, that is again our x value, we can see our point on that graph, which is right about there, tells us that we are at 2, 0, so our output will be 0. So if we do the same thing for -1 and 0, that's basically saying where is our y, or what is our y value when our input is -1. So if we go to our graph, we go -1, we have this point right there, which is going to be up 3. So when g or x is -1, our y value is going to be 3. So that ordered pair would be like this. And then 0, if we look where x is 0, that's this, that should be the origin, I think. Or if we're not moving away from the origin either way, that graph's going to go right through at 0 as well. So we should get 0 right there. So part C, what is the input of this function when the output is 1? So if we're looking at where our output is 1, so our output again is our y value. So when our y value is equal to 1 on this graph, we are right there and right there. So there are 2 different values for that because there's a parabola and it's symmetrical. There's going to be 2 inputs that are going to give us those green points right there where our y is equal to 1. So there should be more than one possible solution here again because a parabola is symmetrical and it goes up on both sides. So good deal. Any questions, please come to office hours or check in the filled in notes for more detail. All right, and the last thing for today is our toolkit. So make sure we have our yellow cardstock toolkits out so we can fill in what we learned today. So our input is what gets plugged into the function. This is usually represented by our x value, right? And then our output is what comes out of the function. And again, this one is represented by y. So if we look at our function notation, if we have f of x, that is equal to our output of y. So for example, where x is equal to 2, if we know that f of x is equal to x squared minus 7, we know that f of 2 is equal to 2 squared minus 7, which is equal to 4 minus 7, which is f of 2. So if we carry our work up here, then we will have f 2 will be equal to -3. -3. All right, and that's all we got for today. So again, if you have any questions or concerns, please come to office hours. I'll let your grading teacher know. Otherwise, come into office hours. But that's all we got for today. Homework for tonight is 1.2.3, so 1-57 through 1-61. Have a great day, everybody, and we'll see you tomorrow in live class.